Hi all, I'm Malavili, Assistant Professor in the Department of Computer Science and Engineering. Today I'm going to take a topic from Theory of Computation. In this, we are going to discuss about the deterministic finite automata. Before going to the DFA, we need to know what is finite automata. Finite automata is a mathematical model with finite number of states. In this, it reads the input one by one and changes the state based on the transition rule. Whether the input is accepted or not is known if it reaches the final state. In the finite automata, we have two: deterministic finite automata and non-deterministic finite automata. Today, we are going to focus only on deterministic finite automata. Deterministic finite automata, where each state exactly have only one input symbol. It have only one state. It does not accept empty moves or empty state. If the here or the input state here the input state is accepted if it reaches to the final state. Now we will see the definitions. The deterministic finite automata is a collection of five tuples m equal to q sigma delta q naught f. Q is nothing but non-empty set of finite set of state. Finite set of state. Next, sigma. Sigma is represented the input alphabet. How many inputs are used in the state? And the next is delta. This is the transition function. And Q naught is the initial stage and F is the final stage. We'll get a clear idea when we go for the problem or example problem. Now we are going to see the graphical representation of DFA to understand the definition clearly. Here I have said the state. A, B, C, D are the state. We represent each state when it moves from one state to another state. Here it moved to one state to another state based on the input. These input are represented by the label 0 and 1. Here the 0 and 1 make the state. For example, when example A goes to B at the input 1. Okay, the arrow mark represents the transition from one state to one state. If it moves, we say this represents the transition. And here the initial state are represented by the arrow mark in the front, and the final state are represented by the double circle. Now we are going to see the transition diagram to transition table. Here if they have given the transition diagram, we need to put the transition table. For example, as I said earlier, the front arrow mark A represents the initial state, the double circle represents the final state. In this, A is the start state and C is the final state. For the input 0, it does not, in the input 0, it is empty. For 1, it goes to B. For B, when it is 0, it goes to C. And when B is 1, it goes to itself B. For C, when it is 0, it goes to itself, and for 1, it goes to B. We need to know both the transition table to transition diagram and transition diagram to transition table to work on with these sums. Here they have given the table. We need to draw the diagram. Here Q0 is the start state and Q2 is the final state. In the table, the arrow mark represents the start state and the star represents the final state. When Q0 when the input is 0, it goes to itself. When it is 1, it goes to Q1. It goes to Q1. When Q1 for the input 0, it goes to Q2, and Q1 for the input 1, it goes to itself. On the final state Q2, when the input is 0, it goes for Q0, and when the input is 1, it goes to Q1. Now we are going to see an example problem for DFA to know whether the string is accepted or not. Here in the question they have given m equal to q comma sigma comma delta comma q naught comma f. As I said earlier, this is the definition of DFA. Here q is nothing but state. Here we have three state, q0, q1, q2, and the input are 0 and 1, and the initial stage is q0 and the final stage is q2. Here we need to, here they have given the diagram, we have to draw the table, then we need to find whether the string is accepted or not. We see where the string is accepted if it reaches to the final stage, that is final step q2. If we will not accept if it does not reach to q2, we need to check whether this string is accepted or not. Here our first step is to create a transition table. For q naught, when the input is 0, it goes to itself. When it is 1, it goes to q1. In q1, when the input is 0, it goes to q2. When the input is 1, it goes to itself q1. q2, when the input is 0, it goes to q0, and when the input is 1, it goes to q1. We have drawn the transition table. Now we need to find the string whether it is accepted or not. As q0 is the initial stage, we will write delta q0 comma the string. Here I will take the q0 with our first input 1. As they given in the string, the first is 1. So delta of delta q0 comma 1 and the remaining string. As we see in the table, q0 comma 1 goes to q1. So we'll write delta of q1 comma the remaining string. In this q1 comma the next string is taken, that is 1 is taken. Then q1 comma 1 goes to q1. So we will write q1 with the remaining string. Here we'll take the q1 with the next string 1. Then I will check in the transition table. It will go to q1 comma I will write the remaining string. Here I will take the next input 0. Then q1 comma 0 goes to q2. Then I'll write the remaining string. Now I'm taking q2 comma 1 and the remaining string. The q2 comma 1 goes to q1 and I'm writing the remaining string. Here I'll check q1 comma 0 go to q2. As it reaches the final state q2, the string is accepted.